welcome to Neural Craft. This is the second tutorial in the continuation of our machine learning hands-on with Python series. So before moving forward, let's recap what we have done so far. So in this tutorial 1, what we did was data understanding. We loaded our data set and then we displayed few rows of the data set. We learned about the dimension of the data set, information about the data types, descriptive statistics, class distribution, and correlation between the attributes. So in our editor, we first we initialized our environment, then we loaded our data set. We came to know about the pandas dot head function, dot shape function, and the d types variable, which lists all the variables for all the attributes present in our data set. So and then we also learn about the describe method and the group by function to get the different classes which are present in the categorical variables. Also we learned about the correlation matrix and how to find the correlation between any two attributes. Then we there was also one more thing, that was the skew distribution. So dot skew function is used to tell us whether our data is inclined towards the positive skewness or the negative skewness, and whether it is the Gaussian normal distribution. So yeah, as you can see here, the skin thickness is very close to 0. So it is more going to be a Gaussian variable. It is following the Gaussian distribution basically. And the blood pressure is negatively skewed, and the pregnancy, diabetic pedigree function, age, they are showing the positive skewness. So as we move towards our tutorial 2, you will understand these terms in more detail, as we would be able to visualize all these things. So in this second tutorial, what we are going to do is we are going to visualize our data. So first of all, why should we visualize our data? As you can see, we can get more understanding based upon the visualization, because once we visualize things, we can understand like in more detail like what is happening, because we will be having the statistics visible to us, and it will be a better and faster way to learn and get more insights in our data. So first thing which we are going to do is, actually we are going to visualize using the plots, because in classical machine learning the plots are the most important tool to get insights from your data, because we can combine different attributes, we can plot them in different manners to find out the patterns in the data. So first of all, what there are univariate plots. Why they are used? They are used because they help in understanding each attribute of your data set. So you can get insights on each and every data set, like each and every attribute in your data set. Like there are basically 3 types, although there are also other types, but mostly you get details from these data sets, from these type of plots. One is the histogram, then it comes another variation called density plots, and third one is the box or whisker plots. So let's have some discussion on histogram. So histogram groups data into bins, or you can say pillars. So based upon the magnitude of the values, you will get different heights of these bins, and it will help you determine which distribution or shape is followed by the particular attribute. Like one attribute might be following positive skewness, one might be negatively skewed. Even you may find some data points in an attribute which are not following any particular distribution, that is called noise. It can also show exponential distribution also, or a Gaussian normal distribution, which you can also call. And this will also help us visualize if any particular attribute carries a outlier or not. So let's first go into our notebook and let's reload our previous notebook with the variable. So as you know, this is the continuation tutorial, so I'm going to use the same notebook. I have just going to run these cells again and again. Now we will just put, I will just put on markdown, and here I am going to hit data visualization. So in this section, first of all, the first thing which we are going to study is histograms. So how to plot histograms? Actually, Pandas provides us a very good method only, with the help of which we can directly plot the histograms. So what we are going to do is, like, which variable do we have? Which I have data variable. So data dot hist. I can also do one more thing before this. This is not going to plot well. First of all, I need to import some things. I will going to plot from Matplotlib, import pyplot. It will help us plot things very easily. Then I am going to just do data data dot hist, and then I am going to do pyplot dot show. But since we have not installed Matplotlib library, we have to first install this one. Then so we will go here and we will write matplotlib, save this file and open our terminal, and then we will just going to do uv add -r requirements.txt. So it's installed the library, and here as you can see now it's not showing any error, and now we can just do shift enter. What you are going to see is now hist plot for each and every attribute present there. So let's have a discussion on them. So first thing is, this is pregnancies. This attribute is having going from high to low in a negative slope manner. This indicates the presence, this indicates that this belongs to a exponential distribution with a decreasing slope. The glucose, the you can see the glucose and also this BMI, and glucose, BMI, and also this blood pressure almost shows the Gaussian distribution pattern. Although blood pressure is slightly positively skewed, and you can see insulin, age, and diabetes pedigree function. These shows us exponential behavior or exponential distribution only. But what about this outcome? Since we know outcome is a categorical variable, it is either 0 or 1. And also from our previous discussions, you can see that we have more number of data points for 0 class, and 268, very less, almost less by half, are for category 1. So here we are not getting any other intermediate values, just only 2 bars, one representing 0 and one representing 1. So this was all about the histogram. Then we will just move towards the next plot, that is going to be density plot. By the way, this thing will help you organize your code very in a very good manner by markdown. With the help of markdown, like, you can just make sections here, like data visualization, it's all inside this. And now here I have created histogram. I can do one thing also here. I can just do histogram. This will help me keep the histogram code neat and clean and packed inside here. So now we are moving towards the density plots. They are another way of getting a quick idea of distribution for each and every attribute. This I can tell you, this plot looks like an abstract histogram with a smooth curve drawn through a top of each bin. So let's implement this. What we need to do is, here we have already have imported here pyplot, so we won't be importing it again. So the thing we need to do here is, we will write this in data dot plot. Now we will need to specify what we are going to do. You can also see in the it's also suggesting, but let me type the density. So because typing your writing your own code is going to make you learn all these concepts. Subplots, what subplots are going to be there? Yeah, subplots true, because we will you will see, there will be, this will be like the histogram only, like we have a grid of 9 plots. Here we will also have the same. What we are going to do is we are going to write a layout is going to be 3 cross 3. We can do any other layout also. Let's start with this basic one, is 3 cross 3 as the previous histogram plot only. Now there is one variable share x is equal to false. I will tell you later what this means, but here I will just keeping it false because I just want a simple plot. Pyplot dot show, yeah, pyplot dot show. Now I'm pressing the enter, and it is showing me there is no module named scipy. So let's go and just install scipy. Open our terminal again. I have added the, and now hope it worked this time. I think it's working. It's taking few seconds because density plot takes more time than hist plot. Yeah, we have them. So you can see for pregnancies, let's have a comparison. Here we are getting this type of pattern, and here we are also getting the same pattern. Okay, you might be saying that it is showing slightly shifted towards right, but no, you can see here 0 is around here, but in this curve we have a 0 at the origin. So at the origin, here the x-axis 0 is shifted, that's why we are getting this curve. This also explains the visualization. It is for better visualization actually. So here you can see glucose. Let's measure from this 0 to towards the right side of the x-axis. We are getting the Gaussian curve for this one. Yeah, as you can see, for glucose, for blood pressure, and for this BMI, we are getting almost Gaussian curves. Although I said that blood pressure is showing a positive skewness, but it's not that much, because here in this plot, after extrapolation, it is showing a smooth Gaussian curves. So the pregnancies, the insulin, and also age, and this diabetes pedigree function, these are showing exponential behavior, but this skin thickness is not showing that thin, because there is some discrepancy in the data basically. Or actually I should not say discrepancy, because data can be anything. Even this data set is a very small data set. Later on, when you will be experimenting with different data sets, you will see that you might not even find these kind of patterns. This is just for educational purposes, so I have taken this data set. So for outcome, you can see there are two smooth you can say lumps, or what, anything you want. So here we are getting 1 and 0 at two different things only. So this shows a categorical variable only, and I think it is scaled down to hundreds, because it is here showing it's showing normalization, or actually normalized output in the y-axis. That's why you are getting this 0.02, 0.01, and 2. Although here you can see it's going above 400. It is actually 500 data points for 0 category, but here it is normalized, that's why we are getting this. So you got what is meant by a density plot actually by here. Now we will move towards our next kind of plot. These are known as box and whisker plots. So first of all, let's go here. So you know, density plots, these are the smooth versions of histograms and provides a clearer view. Now what are box and whisker plots? So boats and whiskers, these are the interchangeable terms, because in this type of plot there is one boats and there are two whiskers basically. So they helps in summarizing the distribution for each and every attribute. uh, they have medians, they have a big box surrounding the most of the part of the data, which is known as IQR. It stands for interquartile region, I will tell you. uh, then we have whiskers and also dots. So what this box does is it is going to give us the bigger picture of our data, like where this, how far our outliers lie to from the mean data, and what does the nth percentile or the quartiles tells us about our data. So moving towards the code now, let me create one more markdown, and this is going to be box and whisker plots. Yeah. So here for boats whisker plot, we also have actually pandas already have provided everything. We just have to utilize it as per our use case. So here I am just going to write data dot plot, and what I'm going to do is I'm going to write kind is equal to box, and then subplots, yeah, it's going to be true, and then layout is the same, share as false, and share y, I'm going to do share y is equal to false. So even earlier what we did was we created 9 different feeders. We didn't share the x and y axes. If we had done that, we might have had a different picture. So if I just show you one here, if I do true, and also let's let's leave it here only. Let's see what happens if I have done share x is equal to true. So in this case, actually in this case we are not getting that much detail, because you can see at the bottom we have 0 and 1000 only, and the feeders have also like contracted in terms of, in the x-axis we are getting very uh, constricted uh, plot. So let's leave it at false only, because this gives us better picture. Similar thing is for share y, and here we have made both the things false, because there is different range for every attribute, and later on I will also tell you what are the different techniques with the help of which we can bring all the different attributes to the same range. So here we have created the box plot. Now we just need to show it, and you can see we are getting different plots here. Let me zoom a little bit for you so that you can see clearly. So let me close this one. Here we are getting box plot for all of the different attributes, but it is not very much clear. So let's use different approach. So instead of just plotting for all the attributes, I am going to plot for each and every attribute separately. I have chosen age as my first attribute, and now I am going to add one more parameter, fit size, and define it like 20 equals 20 for better visualization. Now we are getting a better picture of our data, of our box plot. Before explaining this, I want to explain you the terms which you will be able to find here then on your own. So here I have this image. So this is the box which I was talking about, from which the box name comes, and these are the whiskers. This is the maximum whisker point, this vertical line here, and this is the minimum whisker point. So the lower quartile represents the 25th percentile. This shows how much data is below the 25, how much of your data is where your 25% of your data lies by value. This here it shows the mean, and the median is our 50th percentile, shows how much of your data is below the 50% by value, and then comes the upper quartile, which represents 75th percentile. It shows how much of data lies within the 75% by value, and maximum whisker shows the maximum point and the minimum whisker shows the minimum point, and the dots after that on both the sides of these whiskers, you will see these represents the outliers. So these are the values that are coming too much out of the range of the IQR, which stands for interquartile range, and also this minimum and maximum. We have to treat this point separately based upon our use case, because suppose you have a data set of a real estate where you have some houses which are showing very high prices, and in that case you cannot delete these data points from your data set because they are important, they have very high market value. In some cases there are some outliers which are showing like negative values, and almost 99% of your data set is showing values within this whisker plot. So in that case, what you are going to do, you might want to eliminate those outliers. So it totally depends upon the use case, but yeah, you got the gist, like what outliers tells us and why we use whisker plots. You can understand the skewness, also distribution, where does your percentiles lie for the each and every attribute. So here you can see uh, this is our median line. Okay, one more thing, when our median line lies closer to Q1, then our data is positively skewed because our median is lying towards lower. So it's like um larger values are going towards right, so this will be positively skewed. And then if our median is more towards the right, then it is negatively skewed, and or it is skewed towards left, we can say that. So, and also the minimum to maximum range is 1.5 times the length of this IQR region. So this minimum to maximum, uh, you can get this by extrapolating the IQR region to 1.5 its original size. So this is all about box and whisker plots. Look at the attributes box plot for our attributes from our data set. For age, you can see the median range is below 30 but about 25. The minimum age is also about 20, it's around like 21 something, and the outliers are in the region above 70 or around 70 and above. The maximum whisker point is around mid 60s, and the first and the second and the third quartiles are also mentioned here. So this shows the distribution for the age. Let's quickly have a look at the any other distribution. For let's have a discussion on glucose. So for glucose, there are not much of the outliers. There is one, it is showing that the range around 0. So maybe we will ignore this point. But most of the range is from IQR region is from around 100 to 140, with the maximum distance, maximum whisker points are from around 40 to 200. So minimum value is going around 40 and the maximum is going around 20. So this gives us a clear picture of the what is the distribution of the blood pressure. So if we have a look at here where we can find glucose, it is showing a uniform distribution, and sorry, not uniform, Gaussian distribution here, and also it is visible in the histogram. So it is also depicted here. We are getting the even distribution on the left and the right. Whereas if we have a look at the other one, like we can have a look at this pregnancies, maybe it will give us a better idea of exponential distribution. So if we are just doing this and press shift enter, yeah, you will see that it is more shifted towards left. So in this case, you have a clear picture of what is exponential and what is exponential and what is not. So there are outliers with values going for till 17.5. Yeah, you can also see here around 20 on the x-axis. You can see the values are in the y density is very low, but the you can see the some values are present here which are non-zero, like here at this point. So this shows that the box plot also gives us a better picture. We just don't have to if we are not able to get any insights from the histograms or density plots, box plot is also a helpful tool. So you can also on your own go and check all these different attributes. Since this video is getting longer, I will continue with the multivariate plots in the next video. Thank you.